Good afternoon. My name is Ahmed Rida Sekat. I came from a university in Paris, and I work on the GPAC team. For those who don't know GPAC, I will do a quick presentation, and we'll talk about the key tools in GPAC and latest news. And then I will talk about the delivery of VR 360 videos using tiles, and I will show you some demos at the end. So what is GPAC? GPAC is an open source multimedia framework. It's under the LGPL license, hosted on GitHub, and can be used in all desktops, mobiles, iOS, Android, and embedded Linux. So what do we have in GPAC? Basically, two sets of tools. One tool, which you may know, MP4 Box, which we are happy to call it a worldwide reference for MP4 files manipulation. It does MPEG-dash generation for MP4 files, but not only. We can do an encryption of your files. You can concatenate files, so you can do segmentation. We can also add streams, remove streams, add items, remove items, and things like that. We have also a player, which is a bit more than a simple audio-video player. It's a halfway between a player and a browser. We have support for 3D, 2D graphics. We can use any protocol that you want, including HTTP. You can use almost any codec. We use FFmpeg. We have support for OpenHEVC and scalable extension. And I forgot to say that GPAC is a research-oriented project. Here we have some latest news. So now we have a public test infrastructure. We have support for range extensions for EVC and HEVC. We've improved the TTML support. We have now the support for hardware decoding in OS X, iOS, and Android. And we work into a branch to support more PIFF and smoothing streaming file format, and hardware acceleration in encryption. We have also a lot of interesting projects which you can check in our GitHub. I will talk to you now about the delivery of VR 360 content using tiles. So as you may know, to play a 360 video, it requires at least 4K, but some claim 20K for achieve 4K field of view resolution, like we see in the illustration. And to achieve this, we have the necessity to reduce the bandwidth. We can do this by acting on the compression can do a compression of 2D video after some projection or some shuffling and packing. Or also we can act in the delivery part. We can deliver a part of the video based on a viewport and put a lower quality outside the viewport. But here we have the necessity to react quickly to motion. Here we have some examples of projections. We have the simple one, equirectangular projection, and equirectangular projection with the specific packing. We just take the top and the bottom of the video where we don't need a lot of precision and put it on the top. We can do also a cube map projection with packing. So we think videos will probably be packed and compressed based on a rectangular region. And here's the test for tiling. So the principle of tiling is quite simple. We will just cut the video into different parts, and we have the possibility to play, have the possibility to have different quality in each part. We can also have the possibility to play just some tiles or just only one. So in MPEG-Dash we have a notion called SRD, which represents the 3D relationship between videos. It's in the source content. It's codec agnostic. There is no assumption of tiling coding tools and can be used with multiple independent videos. It's already be used for projected videos, but there is some discussion to extend it to 3D relationship. In our player MP4 client, we have support for two different adaptation. Here we can see using our GUI, we can see here different tiles. In this adaptation, we have actually for this example, we have actually 9 videos, 9 separate videos. So which means 9 decoders, as we can see here different buffers. And we have also an other adaptation which called HVC motion constrained tile-based adaptation. In this adaptation we have just one video, one decoder, and here we can see different tiles, 9 tiles with different SRD and qualities also. So for this second adaptation, after tiling, we encode the video using a motion constrained HVC encoder, and after encapsulation, we have the tile tracks and the tile-based track. After that, you can generate an MPD using an MPD generator to have the MPD file and the MP4 tile segments. Then you can play it with our player, for example, using HTTP requests. You can choose any tile that you want to play, as I said before, or just one tile. Using this link, you can have the whole description of this adaptation and how to encode, how to create files, how to play files, etc. So as we don't have now a standard to choose which quality, which tile to favor, we have some streaming strategies, configuration streaming strategies that you can configure in our player MP4 client. We have a lot of strategies. Here we have 4: uniform priority, row-based priority, center-based priority, or column-based priority. As I said, we don't have a standard, but it can be used with a gaze tracker or a head tracker, for example. Then after this, I will show you a demonstration where we do an adaptation in function of the viewport. So we will have the highest quality on the tile visible, the visible tile. And after that, I will show you a demonstration using demonstration of the implementation of hardware decoding using media codec in Android. So here in MPCAT client, we have this beautiful tool. We can check which decoder is used, we have the possibility to change the bandwidth. We have also, we can see the qualities, different qualities. And now here we have the adaptation. As you can see, the quality will change. It's not very visible, but the quality change in function of the viewport. Here we have a demonstration. Actually, we render just the tile which should be visible, and we can see also the adaptation of the quality in function of the viewport. Here it was very, very visible. So we don't render the other tiles. And here we have the demonstration of the media codec, the difference between the media codec hardware and the software decoder. We use FFmpeg. We can see here that the FPS does not exceed 15 frames per second. We have a lot of drops, and one frame can be decoded in more than 100 milliseconds. But in the other hand, we have the media codec, which can decode one frame in 20 milliseconds and have a constant FPS equal to 25 with no drops. We can see also the cut in this video, and it's quite smooth in the other one. I forgot to say that it is an it's an 4K video resolution. Thank you, and I will be happy to answer if you have any question.
So we have time for quite a few questions, so don't hesitate.
So do you think it's going to become a part of the dash standard anytime soon, like these small description piece for the steams?
So we need to repeat some of the questions.
I didn't actually understand.
So this is not a part of the dash standard yet.
Which part?
Like this.
Tiles?
Yeah, the tiles part. Do you see it becoming a part of the dash standard somehow?
I think it's already in standard.
Yeah, the top.
HVC tile in HVC is.
And the. Okay. Thanks.
I think.
Have you checked the performance with the Facebook pyramid format?
Your question is if we check the statistics using the CubeMap projection?
No, the pyramid projection.
No, we did not have. We don't have it. When?
When constraining the motion vectors, when you were, you said you used constrained motion estimation?
Somewhere on your presentation, you said that you were using motion constraint HVC encoding.
Yes, yes.
So the question is, did you measure any efficiency improvement while constraining the motion vectors? Did you see any improvement?
Yes. Actually, the question is if we did some statistic to see if we have any improvement using tile in encoding videos using the constant motion tile. Yes, we did this, but there is no a lot of difference. But you just need to use 25 tiles, and it's quite good. Yes.
How much bandwidth can you save to get a similar 4K rendering?
The similar?
Yeah. By removing many tiles and better compression, how much do you gain?
I don't know, but how much we gain if we render just one tile or just?
No, with all your techniques, how much do you save compared to the initial full 360 streaming?
I don't know, but we will gain actually. Surely we will gain some bandwidth.
So is the point of tiling the picture? It's not really to benefit in compression efficiency. It's more to optimize the viewpoint according to the bandwidth you have, right?
Yes.
Because you're
Yes.
not always seeing the full 4K picture.
Yes. We don't.
You're just seeing a plot of the picture. So instead of encoding the full picture, you just encode a part, and then you use actually the bandwidth you save on the other tiles to improve the quality of the view you are seeing currently. So the tiling is not necessarily to improve the overall quality of the 4K picture, but it's just to optimize the quality that you are seeing
Bandwidth, yes.
when you are actually
Exactly.
seeing the 360 video, basically. So you're seeing one tile at a time, not all the tiles at the same time.
Yes. But in the encoding, we encode all the time with all the qualities. It's just when we play the different tiles when we do the adaptation.
So does an MP4 box plays on Vive or Oculus or something?
If we support, yes. The question is if we support using MP4 client, if we support all the devices. We can actually in Android we have the multi-view support HEVC. Yes, and we can use it with Google Cardboard. Yes, we can play. Actually, we can play all we support HEVC multi-view. Then you can use to play a multi-view file using side by side, for example, or you play it in a 3D screen. We tested it with five views, MP4 file with 5 views, and we can see we support it actually.
Question? Yeah. What is the target buffer level for all the visible types? Because I assume that since you're targeting a viewport, you can't match the maximum bandwidth because you need to reserve some bandwidth for sliding the viewport. So what's the difference in buffering between the regular
Yes.
and the fact that you are using child?
The question was, what is the difference between the first adaptation and the second adaptation? Adapted a video, play a video, use tile with a lot of videos, separate videos, and using it with just one video. That's the question.
Yes, since you are not targeting single stream or adaptation, you need to reserve some bandwidth for non-viewable types when you are aligned to all your, when your viewport is aligned to your types,
Mm-hmm.
and if you want to scroll, you might need some extra types, so your algorithm needs to reserve some more bandwidth.
Yes.
So you need to make a choice to reserve some bandwidth or to have some less buffering. So what's your current algorithm for this?
The current algorithm, it is the question is which the algorithm adaptation algorithm we use for this using tiles. So here we check just to check just which tile is visible, and we have a configuration, as I said, to choose which quality to use, but we will soon support BOLA algorithm for adapting videos.
The last question.
Do you support 3D? In fact, having two different images?
As I said before, yes,
Okay.
we support. The question is if we support multi-view videos,
Yeah.
multi-view files.
Yes. Yeah.
Yes, we support it.
Okay.
We can play
You
it.
have two streams actually.
We have two streams in one file.
Select.
Yes, we have two streams in one file, and we can play it, as I said, side by side, or choose which view you can.
Sorry.
Yes.
Okay. Thank you very much.
Thank you.